Authentication. In this topic, we're going to take a look at authentication. Specifically, we're going to take a look at single sign-on for your Google Apps domain. In the topic list, we're going to take a look at what is authentication, the default authentication model, building a custom authentication model, which is typically a single sign-on system, and we're going to take a look at, most importantly, is scenarios and the architecture of those scenarios. What is authentication? Well, it's a mechanism where the user can say who they are. Are you John or are you actually Mary? That is the first part of authentication. And I call it a cousin of authorization, which is answering a different question, is what can this user do? So when John logs in, what access do they have to the services of Google Apps? And when Mary logs in, what access do they have? It does not have to be the same. So the default authentication mode for Google Apps is where the user is in their browser and they authenticate into Google directly. The password is stored at Google and the user will then put in their username and password and Google will do the authentication. Google will say, is this user who they say they are? So step one, we see here, user starts here in their browser. The user goes to the URL for Google Apps. Google Apps will prompt them for their username and password. Following that, in number 3, once the user has been authenticated, the user will be returned back to their browser and they will then have access to the services that they have authorization for. And in the default authentication model, this is typically what we see is the username and password prompt within the web page of Google Apps. So we'll see the username and password. And this screen here is not customizable. Now, many customers of ours, with their Google Apps implementation, would like to create a customized authentication mechanism. And the typical business case for that is the users want a single sign-on experience. They authenticate once, and then that will give them access to all the services, not just Google Apps, but all the other business services that the organization provides that require authentication. So if a Google Apps customer would like to use their own store for their user management, they would like to have the control of the authentication process, and basically take over the control over the is this user who they say they are question, implementing a single sign-on system with Google Apps is what is required. So in this scenario, we see here the blue, which is the user's browser, green, which is Google Apps, and the purple on the right-hand side is the third-party system. Third-party could be a hosted system. We have a number of partners who provide that for Google Apps. It could be something built by the customer themselves. So let's take you through the steps here. Number 1, we start here with the browser. The user tries to reach Google. Now in this model, what you're going to configure is to say Google Apps do not handle the authentication anymore. We're going to let the third-party single sign-on system manage this authentication. So that Google will, when it gets this request to authenticate the user, Google will say, I don't authenticate users, but I know where you can get authenticated. Once you've been authenticated, come back to me. So step 1, go enter the URL. Google Apps says, I don't handle authentication, so we'll move back to the browser to step 3, and the browser will be redirected. So Google Apps will provide the URL for the redirection. Now, once you're redirected to the single sign-on provider, the SAML request will be processed by the single sign-on provider, whether it be a custom or an off-the-shelf product, hosted or in the customer's data center. Now, when this happens, the users then will be authenticated. Now, how will the authentication happen? Well, typically it's username and password. It could be username, password, and a token from some sort of two-factor system. It could be iris scanning. It could be fingerprint scanning. However that single sign-on system has been built, it can handle those mechanisms. Once the user has been authenticated, then the identity provider will send that response back to Google through the browser. Now that's in step 6 once the user, so step 5 is after the user has been authenticated and will generate a SAML-based response. That SAML-based response will be sent back through the browser to Google Apps. Now that response is digitally signed. Why is it digitally signed? Well, a couple of reasons. One, we want to make sure that it came from the approved identity provider. So it's signed with a private key. So in the purple, in step 5, the SAML-based response will be signed with a private key. And in step 7, that will be decoded with the public key. And that will verify to Google that this is the real identity provider, not a rogue identity provider. The second reason that this response is signed is so that we know that when Google reads that, it knows that it has not been tampered, that has not been adjusted. So if the user does not have access, that doesn't say that they do have access or that the name is changed. So we want to make sure that that has happened. Once the user SAML-based response is approved by Google, then the user will have access to Google Apps. So this is an example of a custom authentication model that clients can implement with their Google Apps deployment. Let's once again review the digital signature. So there's two pieces, as I mentioned before. There's origination and integrity. So origination is, did the response come from the approved identity provider, not some rogue one that someone else has created, but from the approved identity provider that has validated that this user is who they say they are, has authenticated the user. And secondly, integrity. We want to ensure that the response that came back from the identity provider has not been modified in any way. And so this is why we sign that with a private key. And Google Apps will need the public key. We'll need that to be able to decode the message. So in the control panel, we're going to take a look at this further in the demonstration that will follow. You will enable the single sign-on feature, and we will need 3 URLs. The first URL is the sign-in page. So that is what we saw earlier when the user went to Google Apps and Google says, well, I don't handle authentication anymore. So by checking the checkbox, enable single sign-on, that ensures that we don't handle, that Google Apps no longer does the authentication. And then Google Apps will need to know where to send the user to be authenticated, and that's what this first URL does. The second URL is when the user signs out of Google Apps, where do you want to take the user? So that's what we need to provide next. And the third one is the URL when the user clicks on change password. So in Google Apps, for example, when you're in the user's account information, they can go ahead and modify their password. There's a link there. Where do you want the user to go? So this is customizable through this mechanism. You enter the URL here. If no URL is entered, then we would go to the Google Apps password setting change, which is not what we want. And finally, we'll have to add the certificate. And this allows the response coming back from the identity provider to be read. So this is the public certificate that Google Apps will use to decode the message that came back that was digitally signed with the private key from the third-party single sign-on system, the identity provider. A couple things to consider. Passwords will obviously remain private. So your password in Google Apps is typically not used when you implement this. So that's one thing to remember. The password that is used can be duplicated in both systems, and we'll talk about that in a little bit. But the usernames must be the same. You cannot have one username for Google Apps and a different username for the other system. So that's one thing that can cause issues when clients want to implement a single sign-on system for their Google Apps implementation. This is one of the reasons why we recommend to not implement a new single sign-on system for Google Apps. And the reasoning is that if you implement that at the same time as your Google Apps deployment, you could derail or increase the time to deploy. Remember, for a typical Google Apps deployment, we're recommending between 45 and 90 days for your deployment, depending on how large it is. So obviously the smaller deployments in the 45-day range, a 500 to 600 person deployment in the 60 to 90-day range, and larger deployments in the 90-day range. So adding a new single sign-on system adds additional complexity to your Google Apps project, and thus it's not typically recommended to implement that. What we recommend as a short-term solution is to first implement the single sign-on system after the Google Apps deployment has gone live. So you would be using the password stored at Google, and then once that has been implemented and everything is settled down and you're having a good deployment with all your users in Google Apps, then the next phase would be to implement a single sign-on system. Also note that a single sign-on system can get authentication from your directory service. It's typically what most customers do, and once again, that can also cause complexity. We see one of the reasons why customers move to Google Apps is they want to move to a single mail system, and thus they may have had several companies that they're consolidating together. Be careful when trying to do all of these things. I think these are all great ideas to implement single sign-on and consolidate your directory service, but during the deployment of Google Apps, we'll recommend to perhaps hold those two projects till after the go live of Google Apps. Now, a couple of things. There are times when the password at Google Apps is used. So when you create your user initially, the password can be assigned by Google Apps automatically. And if you do that, unfortunately you won't know what the password is, but that's also a good security mechanism if you're not planning to use that password. Now, there are a few instances when you will need to use the password stored at Google. One example is when you're using ActiveSync to sync your mobile device, using POP or IMAP synchronization with a mail client on the desktop are reasons when you need to use the password stored at Google. Also, the administrator password for access to the control panel in Google Apps is also stored at Google Apps. It's not the one stored in the single sign-on system. Additional resources can be found at this URL for single sign-on if you're going to be building your own. Now, one of the key points here that you can see on this reference page here is that Google Apps supports SAML version 2.0. So you cannot use a SAML 1.0 compliant system for single sign-on. You need to use a 2.0, and that can cause problems. Those people might be using other systems to integrate. One classic example that we have seen is the integration with Postini. Postini does a SAML 1.0 based specification. So for integrations with systems such as Postini or other systems that you have that supports 1.0, you won't be able to implement this. Also remember that the two-factor authentication provided for Google Apps does not support single sign-on. So for many of our larger customers who like to use a single sign-on system may already have a two-factor mechanism built in, and typically that wouldn't be an issue. But for our mid-sized and smaller customers who would like to implement a two-factor system and like to use the Google Apps mechanism that's available, they cannot unfortunately use the single sign-on system today. I want to take a look at some scenarios to help people understand the implementation of the single sign-on system. So one of the questions often customers ask about is, what about internet access through an internet cafe for Google Apps? So that, first of all, is a policy that the client will need to determine. So the Google Apps customer need to determine if that is an implementation that you want to allow. Typically, though, without single sign-on, you will have access to Google Apps at an internet cafe. And there are some other mechanisms to help manage that better. But let's take a look at this. If you're implementing single sign-on and you want to have or not want to have access to the single sign-on system, that's kind of the key piece here we're showing. We have the user, and the user is accessing Google Apps. And the note here is that the single sign-on system is outside the firewall. So because it's outside the firewall, the user will have access to the single sign-on system. The single sign-on system will talk to the user store to verify the user, that authenticate them, that they are who they say they are, and then give them authentication, and then send that back to Google Apps, and the user will then access Google Apps. So the key thing here, if you want to provide access outside, with non-corporate issued computers at any location, then we need to ensure that the single sign-on system is outside the firewall. Now, some clients like to implement the single sign-on system behind the firewall only, And for that to occur, what we'll need to do is the user, to be able to access the SSO system, they'll need to go through a VPN tunnel. Because if they don't, they won't have access to the single sign-on system, and thus they will not be authenticated, and thus will not have access to Google Apps. So in this case here, the user who's in the diagram here will have typically a corporate issued computer or instructions to install the VPN client on their machine. And from there, they will then access the single sign-on system. Once first enabling the VPN tunnel, then they'll have they access Google Apps, they get the redirection to the single sign-on system. Single sign-on system will authenticate the user, provide that authentication mechanism validation to Google Apps, and then the user, the key thing on this, once the user has been authenticated to Google Apps, the user no longer needs to have the VPN tunnel. So you can actually turn that off once the user has been authenticated. Now, one of the things that you can run into here, which is not a recommended practice, but let's say the user is a business user traveling on business and the corporate headquarters is in New York, but the user is traveling in Hong Kong this week. So users in Hong Kong accessing Google Apps, and they're using their VPN tunnel. And so what will happen is their IP address to Google Apps will potentially be incorrect. And so the user will be potentially accessing a server in New York for their front end. So their front end, we try to have the user as close to our infrastructure as possible. You can run into these slight anomalies depending on how the traffic is routed through the client. As we've mentioned in another session, that you want the user to have their local IP address so that we can provide them with the information the quickest and fastest as possible. Note, when the user disconnects from VPN, it does not terminate the Google Apps session, which is fine. I believe that's not a problem, but we know some clients would prefer that the user does have access to Google Apps only when they're into VPN. It may be that their Google Apps system might be tightly integrated more with some back-end systems at the client, and so this would typically make sense in that scenario. But if they're just accessing mail, calendar, not necessarily required, but those customers who would prefer to only have access to Google Apps when the VPN is connected, when you terminate your VPN, we'll need to clear the Google Apps cookies to be able to make that. So that's something that have to be built. It's not a service that's in Google Apps directly. Mobile access, well, mobile phones, they're just like a computer when you think about just the web browser. So once again, this is a scenario when mobile users are accessing Google Apps, they would go through the single sign-on system. If they're accessing the single sign-on system through their web browser. So this is a web browser solution, not the solution where the user is using a mail client on their mobile device. So if they're accessing the single sign-on system through a web browser, very similar to a desktop, no changes. Now, many of our users who are using a mobile device are accessing Google Apps with a client. So in those cases, if you're doing that, will depend upon the OS and what's been configured. So one option is if they're using an ActiveSync device, such as a Windows Mobile, iOS device, such as an iPhone, iPad. In those scenarios, we'll be using ActiveSync, and ActiveSync will require the password stored at Google. So you would bypass the single sign-on system. For the Android platform, it can use either or. Now the single sign-on systems that are valid are limited, but that is possible to do single sign-on with the Android platform, but also we could use the password stored at Google. We mentioned once again the IMAP client, and this would apply also to the ActiveSync devices. This is revisiting once again that those types of connections don't use the password through the single sign-on. We use the password stored at Google Apps. So some clients will synchronize the password. There's a API, the provisioning API will allow you to build your own utility to sync the password between Google Apps and your user data store, however you choose to do that. Typically when that is the way they do that is when the user does a change password, when the password is being written, we write it to two places, once to Google Apps and second to the store. Systems such as Active Directory does not allow to fetch the password directly from the password store in the Active Directory. So that's why typically these systems that do the syncing would do the syncing at the point when the user changes the password, because we then at that point know the password. So reminder, not all accesses will use the password stored at Google, depending on how you've configured and what features you're using. Active Directory does not allow us to use the password, and for ActiveSync devices, IMAP, we use the password stored at Google. So passwords, as I mentioned before, replication. If the passwords between Google Apps and SSO are not replicated, we'll require two passwords. So one for the IMAP and one for the web access. So one thing to remember, that it's possible actually to have two passwords if you're not going to replicate the passwords, and some of our clients do that. When you implement a single sign-on system, the password for the IMAP client will always be the password stored at Google. So that can provide a limitation, but it can be used in a way when you want to limit those users who have access to IMAP on their desktop client or their mobile phone client. To implement this solution, the users who you want to have IMAP access, you would let them know what their password is. Either A, synchronize the password from the single sign-on system only for those users who will be using IMAP client, and so they can use the same password, or B, configure the password in Google Apps for those users who will have access to IMAP, and then communicate that password to the users who will have access. Everybody else will try to use the same password as Google Apps, but since the password is not synchronized to Google Apps from the single sign-on system, when they try to use their SSO password, it will fail and they will not have access to IMAP. Some people are mistaken. The IMAP client access limitation, it's by domain only. You can turn the IMAP feature on for the domain or off for the domain. It is not possible to turn on and turn off IMAP feature by organization.